Hello friends, welcome to Code with Fun. In the previous video, we have seen how can we convert decimal to binary using operators, that is arithmetic operators or bitwise operator. In this video, we're going to discuss one trick where we can use this conversion. Uh, so coming to this value here, previously we have seen if the number will be 12, then the binary representation of 1100, and how can we derive it from there to there. We'll divide 12 by 2, then we'll get 6 and the remainder will be 0. Similarly, 2 divided by 6 is divided by 2, then value is 3 and remainder will be 0. Similarly, when 2 is 6, 2 divide 6 3, the remainder will be 0. Similarly, 2 divide 3 by, will get quotient 1 and remainder will be 1. So from lower to upper, if we'll go move, then 1100, which is similar to this value. This is what we discussed earlier. But here I'm going to discuss about one trick, one shortcut which you will use to find the same value. There is nothing shortcut actually. There is we have to remember something in our mind, and based on that we'll write our result. Let's have an example and see. If we'll take 12 as an example, as our example, then there is nothing but the simple thing is that we'll get one answer. We'll get our answer like here. Here we'll see 12. 12 is odd or even. Since 12 is even, then we'll divide an even number by 2. Then what will be the remainder? The remainder will be obvious 0. And if we will divide odd number by 2, then what will be the remainder? Remainder will be obvious 1. Like here 12 and 6 are even numbers, the remainder will be 0. And if here 3 is an odd number, so that's why remainder will be 1. So based on this logic, we'll write our answer. So 12 is even number, so we'll write 0. Then again we'll um, uh, will divide 12 by 2. The value will be what? 6. So after seeing 6, 6 is what? We'll write our result from right to left. First we'll write 0 right side, then we'll write left side. 6 is again an even number, so remainder will be again 0. So we'll writing the result from right to left. This is one thing you have to remember. Just divide the value and write the remainder. 6 is divided by 2, then 3 will be there. So in for 3 or for 3, what will be the remainder? 3 is an odd number, so remainder will be 1. So for even we'll write 0, for odd we'll write 1. Simple thing. Again we'll divide 3 by 2, then the value will becomes 1. We'll see 1 is an odd number, so simply we'll write 1. Simply we'll write 1 here. So you can see we have follow the way right to left, like we have start from right and ending going towards left. And what we have to remember? We have to remember the value is even or odd. So 12 is an even number, so 0. 6 an even number 0. 3 odd number 1. 1 odd number 1. Till 1 we'll stop. This is one example. Similarly, I can take another example, like take 10. 10 and the binary format is 1010. This is the binary format we have used. So we can get this binary value using this logic. You can find, but using trick I can discuss how we'll get this. So simple one thing we have to remember, we have to write from right to left, and second one is divided by 2 each time. We'll see the value and check it is even or odd. If the value will be even, then we'll write 0, and odd it will write 1. So let's start here. So for the 10 first. 10, what is 10? 10 is even number, so we'll write 0. Then what is the half of 10? 5. 5 is an, okay, wait. What is the half of 5? 10, 5. What is 5? 5 is odd. So what should we write? We have to write odd 1. We have to write 1 for odd. Okay. Then we'll again divide 5 by 2. Then value will become 2. 2 is what? 2 is an even. So what do we have to write? We have to write 0. And then again we'll divide 2 by 2. 2 by 2. Then what we'll get? 1. 1 is what? 1 is an odd number. So for odd we write 1. So here we write 1. Two things we have to remember, and from one this is the decimal value. We have to write from right to left. We have to write from right to left, and we'll get our result. For 10, it's an even number, so we'll write 0. 5 odd number 1. 2 even 0. 1 odd 1. So for even number we have to write 0. Odd number we have to write 1. We have to move from right to left during writing, and we'll divide each time by 2. These 3-4 things we have to remember, and we'll get our value. Practice this thing more and more. We'll get the you will hands on this. You will experience this logic once. Then you will face more benefit of this logic. So here we're going to discuss from binary to decimal. How can we get binary value, sorry, decimal value from binary value? So for that I'm going to discuss one the basic logic we used for conversion. It's like if 1 1 0 and 0 will be there, then what we can do, this is the binary value which represents what 1100 means 12, decimal value of 12. How can we get 12 from this value? How can the calculation has been done? So the thing is that from right side, okay, from right side we will start, and what we'll do, we'll we'll just write 2 to the power 0. 2 to the power 0. We'll move leftwards, and we'll increase the power 2 to the power 1. Then we'll write, how we will write, we'll write 2 to the power 2. Then we'll write here 2 to the power 3. We'll write like this. Then nothing is much. We'll just multiply these values, 1 and to the power 3. Then this multiply will multiply individual values, and we'll just multiply these values and add. Like this one is block. Similarly 4 block is there. 4 block is created actually. This 4 block is created. Will nothing that will just multiply this and add the individual results. Will add the individual results. Like if we multiply, if we'll see 0 on top, then result will be 0. We'll see, so result will be 0. So what we'll do here, if we'll see from right to left or left to right, how can we conclude? If 1 is there, then we will calculate here 8 plus here 1, then value will be 4, to the power 2 is 4, then plus here 0, so value will be 0. If topmost value will be 0, then output will be 0. If 0 multiplied by 0, the value will be 0. Here itself value is be 0. Then we'll add these values, then what we'll get? We will get 12. If you try to get, then we'll get 12 as a result. 8 plus 4, 12. This is the method we use to solve this is the method we use to convert decimal value from binary inputs. But here I am going also use a trick. Trick is what? Trick is simple. We will do whatever we have done here, but there is some special things we have to notice. We'll have to note it down. Like if number 00001100, if this is the input, what we have to do? If this is the input, we have to do nothing. We have to do nothing. We have to simply, if this binary value is given, this is nothing but 12. So what we have to do? We will do nothing. We'll just go in front of the first one from the left side. So this is the first one from the left side. Okay, this is the first one, right? So we'll write 1 is in the 1 below it. Then we'll double this one, double this value, and add this next value. So listen again carefully. Go to the first one we'll get from the left side and write 1 just beneath of it. So for 1 here I am getting left side first one will write 1 here. Okay, for the next value, how you can calculate? We'll double the result and add this value, whatever here 1 will be there, 0 will be there, just add this value. So 1 into 2, 2 plus 1, the next value will be 3. Okay, similarly 3 into 2, double the value of 3 and add the next one. So 3 into 2 is 6 plus 0, that is 6. 6 will be right here. Then again 6 into 2, double the value of 6. For getting the next one, double the current one and add the next value. So 6 we will 6 into 2, 12 plus 0. What will be? The value will be 12. So here we get our result 12 after doing this. So what is the procedure? Just check the first one from the left side and write 1 just beneath of it. Then for getting the next value, just double the current value and add the next value. For 1, double the 1, that is 2 plus 1, 3. 3 into 2, 6 plus 0, 6. 6 into 2, 12 plus 0, 12. And finally at the last point we'll get the get our result 12. So this is nothing but the binary representation of 12. Here I have included these two zeros just because to understand you that how we have to ignore the zeros before 1, because it will be creating one questions in mind. So I will take another example for 10, for value 10. So for value 10, what we have to do? We have to nothing do much more, just a simple things will be 0. Simple things. If for 10, if 10 will be the input, or the binary representation of 10 will be 1 0 1 0. Just simple thing. We'll just do nothing, we'll just write something. This is the first one, so we'll write 1. This is the first one from the left side in the binary representation of 10. So we'll write 1 just below the 1. Then for the next value, for this value, what we have to do, we have to double the current value into double the current value plus next value, this one. So 1 into 2, 2 plus 0, the value will be what? 2. Then for this result, the cursor is blinking there. For this result, what we have to do, we have to double the previous value plus current value. So previous value is 2. If you double the previous value, then it will be 4 plus 1, so it will give 5. Then 5 into 2, 10 plus 0, then 10. At lastly we'll get our result 10. So this is the trick. By writing in this way, you'll get your answer very efficiently. You don't need to calculate in this way. You'll get this value very efficiently by this. I hope this will help you to understand better, and the conversion will be very easy or handy for you. You have to practice a bit, and this thing will be handy for you, and it will be help you very much in the conversion things. So if you think this video will be helpful for you, please like and subscribe my channel and share this video to your friends for helping them. Okay, thank you. Bye bye. See you in the next video.